Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Fikar Ibisbawi. My notice number is AE10041. We are from Busik for the Power Electronic Section 2. Our title for this project is Application of DC buck power converter in DC motor for laptop cooling pack with 5V DC rated voltage. The first thing I want to talk about the introduction. A fan is a mechanism that uses electricity to produce a flow of air. A fan is made up of a spinning arrangement of fans or blades that operate on the air and are usually constructed of wood, plastic or metal. We can see that laptop or notebook cooling pack or chill mat is a laptop computer accessory that helps lower the operating temperature. In this project, we apply the DC-DC buck converter to making this cooling pack in order to reduce input voltage from 12V to 5V. Okay, next, our objective. In this project, we want to analyze a power electronic converter against a set of criteria. Using a suitable modeling tool, simulate the converters in action. And the last one is identifying the concerns or issues that have arisen. Okay, that's all for me. I will pass to my others member. Thank you.
Good day everyone, my name is Ishwajit. My face card number CE200095, and today I will be explaining about the methodology of buck converter and how to apply it for our project, which is the application in DC laptop cooling pad. Power supplies are critical equipment for meeting the need of wide range of electrical devices with the primary purpose of achieving a steady high efficiency output with increased dynamic performance. So what is buck converter? Buck converter is also known as step-down converter. It's a DC to DC power converter that reduces the voltage from its input supply to its output load. It's a DC-DC converter, therefore it does the task with the help of few transistors, switches and an inductor. So this over here is the buck converter circuit. This is the input supply, this is the diode, inductor, capacitor and the load. Alright, so this is the load and these are the voltage and the current, right? This the switch over here can be replaced by MOSFET, IGBT and etc. right? This here is the design planning flowchart of buck converter. So first of all, we need to design the criteria as we have chosen for this project 12V as input and 5V as the output. And to design it, we need to set the component values to know the voltage source, what switch we are using, MOSFET, the diode, the filter inductor value, filter capacitor value and the load resistance. And after that, we will be referring to manual calculation of selecting the inductor, capacitor and diode, followed by the simulation of buck converter in Simulink MATLAB. And then we will be monitoring the pulse generator graph, whether it exceeds the 5V or not, and troubleshoot it if it exists. And in the end, we will make an analysis of the result and discussion. So that's all from me. Now I'll pass to my team. Thank you.
Assalamualaikum and hi, my name is Nur Aiman Zainal. My metric number is AE1900049. This circuit design for DC-DC buck converter using Simulink MATLAB software. Initially, duty cycle was set as 0.4167 based on calculation part. Next, if moving to PWM generator, duty cycle will be input that specify a signal with value between 0 and 1. Pulse will be output and going to MOSFET. In this buck converter, we preferably using frequency 10 kHz. After that, with output pulse to fire MOSFET as switching frequency buck converter. Continuous conduction mode current was used in buck converter because of the changing current inductor is greater than 0. For output voltage, we get 4 0.983 volt. It means less than 5 volt. That voltage we expect to get. Then for voltage ripple is 0.0818%. Since the output ripple is sufficiently small, then assumption of constant output voltage was reasonable. On the other hand, current for inductor we get 0.4045 ampere in this simulation, but for calculation we get 0.0442 ampere. It shows slightly different because of the output voltage in simulation than less than 5 volt. Moreover, we also connect inductor with 3.3 millihenry inductance value, capacitor with 217 microfarad capacitance value, and for load we use resistor with 11.11 ohm. We also connect voltage modulation to get the graph for output voltage. Finally, for the input voltage, we also connect with voltage modulation at battery that we set 12 volt to get the graph. That's all for me. Thank you.
Good day everyone, my name is Muhammad Shafiq bin Kasmazuli and my message number is AE100107. Now I will show you the simulation on our assignment. So this is a DC-DC buck converter. So here, this is our battery or our voltage source, which is 12 volts. And this is our duty cycle 0.4167. Our diode, we have our MOSFET, and our frequency we use is 10,000 Hz. And this is our inductor, which is 3.3 millihenry. Our capacitance is 270 microfarads, and our load, which is our fans, is 11.11 ohms. And here is the display of the voltage load, and here the display of the current, inductor currents. And now we run the simulation. So after we run the simulation, we get here our voltage load is 4.983 and our current is 0.4045. So as we can see that the voltage output here is less than the voltage input. So this means that our circuit is perfectly in a good connection here. So and then this is our graph waveform. So here we have a photo of waveform here. For the blue one, we have a current measurements. For the red one, we have the output voltage here, and for the yellow one, this is for the input voltage, and here is the current for the diode voltage, or we call it a PWM generator DC. And now I will try to zoom the graph here. So here is the basically graph of the current measurement here. So we get that our currents, the value is in static value here, which is 0.4045 current, and our voltage is here 4.983. So this is our outputs and our inputs. So from here we can see that our maximum and minimum, mean, median, RMS, same goes for VM1, which is our output voltage. You can see that our maximum, minimum, mean, medians here, and this is our diode voltage or PWM generator, DC, maximum, minimums, and this is our inputs, 12 volts. So that's all for me. Thank you.